Okay, the graph of a quadratic has vertex minus 2, 8, passes through minus 1, 7. What does this all mean? The vertex is at 2 to the left and 8 up. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Vertex is about there. And then it goes through minus 1, 1, 2, 3, 4, 5, 6, 7. Notice that point is lower than the vertex. The only way that's possible is if this curve opens down. It's got to be shaped something like this. Don't pay too much attention to where I put the X-Intercepts. I'm guesstimating those, but definitely it has to open this way. Now, these can tell us some very specific things about the equation if we treat them right. First of all, the really nice one, these numbers are P and Q in our equation. P and Q are exactly the location of the vertexes. So just from this fact, we know our equation has to be y equals a. I'm not sure what a is yet. We'll get to that. X plus 2. You're saying, but wait, this is a minus 2. Notice the equation is x minus p, so it's x minus negative 2. This is where we get that thing about the horizontals always being backwards. It's because we have a minus here times a minus here. You end up getting a positive value. And then plus q, in this case, means plus 8. So that's really great. Of the 3 parameters that you can change in a quadratic, a, p, and q, we got 2 of them without doing much of anything. Just translate them over. The one we don't have nailed down yet is a. And we can find a because we know this curve has to go through minus 1, 7. What this means is when x is negative 1, y has to be 7, which tells us this. We can write this equation again. I'm going to plug in the x and y values. Y, 7 from here, equals a, don't know it yet, but I will soon. X is negative 1 plus 2 all squared plus 8. 7 equals a. Negative 1 plus 2 is 1. Squared is still 1. Plus 8. Subtract 8 from each side. Negative 1 equals 1a. And the 1 is just fluff. You can just say that a is negative 1. So I'll rewrite this one more time now that we know what a is. The complete finished version is y equals negative 1 x plus 2 all squared plus 8. If you just wanted to write a negative here instead of a negative 1, that also would be okay. There. Rewrite the equation in general form, la 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 la. Okay. They want it expanded into general form. What that means to us is we need to multiply this out. Where this says x plus 2 all squared, we're going to FOIL it. We have minus 1 times x plus 2 times x plus 2 again, and then we have our plus 8. When we FOIL this, we get x times x, then we get x times 2 is 2x, 2 times x is another 2x, total of 4x, and finally we get 2 plus 2. And our plus 8 is still hanging around here. This negative 1 distributes through the whole works, so it hits all 3 of those terms and turns them all negative. So we get y equals minus x squared plus 4x. I'm sorry, minus 4x minus 4. And then we have our plus 8. And if you collect like terms here, you get y equals minus x squared minus 4x, and negative 4 plus 8 makes plus 4. So this is the equation in standard form. This is the equation in general form. Use a graphing calculator to sketch the graph and determine the x and y intercepts of the graph of the function. Answer to the nearest hundredth if necessary. Okay. Here is a calculator. Which form of this do you put in? It really doesn't matter. It's maybe slightly easier to enter this version, but just to prove that this one works, I'll use it instead. Negative x plus 2 all squared plus 8. Okay, there it is. we want to find the X-intercepts, also known as the roots, also known as the zeros. Let's tackle those first. Calc 0. You move the little bug here until it's to the left of the root you're trying to find. Then you move it to the other side. It puts these two little marks saying I'm going to search in this region to find a root or a zero. Minus 4.8. What did they say? They said nearest hundredth, so that would be minus 4.83. On the other side, second calc 0. If we're just left of that other root, that's pretty good. And now just to the right of it, now we get 0.83, positive this time. So that's our two X-intercepts. The Y-intercept is what happens when X is 0. You can do that with the formula just by saying if X is 0 here, then we get 0 minus 0 plus 4. Y comes out to 4. You can do it on the calculator if you want to. You go second calc, and then you pick value. And value just lets you plug in any X value that you want, right? So now it's saying, okay, what X do you want? You can put in 16 or whatever you like here. We're putting in 0 to find the Y-intercept. It marks it on the graph, and sure enough, it tells us Y is 4 when that happens. So, X-intercept at minus 4.83, that's this one. X-intercept at positive 0.83, and Y-intercept at 0, 4.